Okay, for this foldable, it's going to be a quick reference sheet on the names of polygons based on their number of sides. So all you're going to have to do is write down the name given the number of sides, which I'm betting a lot of you know all of these already. So I'm going to go through them. You can write them down. Make sure you push pause if things are going too fast. We all know that a three-sided polygon is a triangle. A four-sided polygon is a quadrilateral. There's lots of different types of quadrilaterals. There are squares, rectangles, rhombuses, parallelograms, but they all have four sides, making them quadrilaterals. Five-sided is a pentagon. Six-sided is a hexagon. Seven is called a heptagon. 8 is an octagon. We skip 9. 10 is a decagon. And 12 is a dodecagon. So you should know all of these names at the top of your head. So if you don't know like the decagon and the dodecagon or the heptagon, you want to spend a couple minutes making sure that you've got those down. Go ahead and tape this in your notebook before you move on to the next step. Okay, we're going to make a quick foldable here for the interior angles of a polygon. So you're going to want to find this sheet of paper and follow along so that you have something to reference for in your notebook. Remember, it's a good resource for a unit test that you'll be able to look back on. So there's two ways that you can find the degrees inside a polygon, which is any shape with any certain number of sides. The first method that you can do is you can split the polygon into triangles. And then number two, multiply the number of triangles by 180 degrees. Okay, this one you're going to have to actually draw out the shape if it's not drawn for you and split it into triangles. The one drawback is that if it's a really big shape with lots of sides, you're going to have lots of triangles. So not the most convenient method, but we'll do an example with a pentagon with this method. So you draw a pentagon first, and then split it into triangles. Okay, then count the number of triangles in the pentagon. So I've got 1, 2, and 3. Okay, then I take those triangles, 3 triangles. Each triangle has 180 degrees. So I multiply 3 times 180. Okay, and when I do 3 times 180, I get 540 degrees. So a pentagon will always have 540 degrees. The second method is the shortcut formula. And a lot of you like shortcuts, so I think you'll probably prefer this method the best. But in the shortcut formula, you're going to take the number of sides and subtract 2. You're going to do that first. That's why it's in parentheses. And then you're going to multiply that by 180 degrees. So if we do an example with the octagon, I don't even have to draw out the octagon, but I know that an octagon has 8 sides. And so I do 8 minus 2 times 180. And first I have to do 8 minus 2 first, so always subtract 2 from the number of sides. That's a common mistake, which is 6. And then when I do 6 times 180, I see that equals 1,080 degrees. So in every octagon, there will always be 1,080 degrees. In this method, do not forget to subtract 2. Okay, now we're going to take it one step further. We're going to try to figure out the degree of each angle in a regular which means all angles are equal polygon. So the word regular is important here. You'll see that we have a 5-sided figure, a pentagon, and because it's regular, it means that all of these angles are the same degrees. So you can go put those little congruent angle marks in each corner. So not only do we have to figure out the total, but then we have to figure out what each of these angles is separately. But once we figure out one, that'll be the same thing for the rest of them because they're all the same. So the way we do this is first we start with the sum of the angles. So figuring out the total degrees in the pentagon. And then we divide by the number of sides or angles, which are the same thing. If there's 5 sides, there's also 5 angles. And that'll equal the measure of each angle. Okay, so what we're going to look at here is this pentagon, and our goal is to find out how many degrees each of these individual angles are. But remember, once we found one of them, we found the answer to the rest of them because they're all the same. So first things we need to do is we need to count the sides. We've got 1, 2, 3, 4, 5 sides. So to find the total degrees, I take my 5 sides and subtract 2. Then I'm going to multiply that by 180 degrees. So 5 minus 2 is 3, and 3 times 180, I use my calculator, equals 540 degrees. So what this tells me is that there's a total of 540 degrees in the pentagon, which we've kind of already looked at because we've worked with the pentagon before. But now my goal is to figure out how many degrees is this angle, this one, this, and this. So there's 5 angles here that add up to be that 540 degrees, and all of them are the same. So now what I'm going to do is I'm going to take my total 540 and divide it by the number of sides or angles. Well, there's 5 sides here, 5 angles that I have to split this 540 degrees into. So I'll start with my 540 degrees, my total, and divide it by the number of angles. There's 5 of them. And if I do 540 divided by 5, that equals 108. So that means that each of these angles is 108 degrees. So I'm going to write on our pentagon, this angle is 108, this is 108, 108, 108, 108. So all of those together would add to equal 540 degrees. Now this only works if it's a regular polygon, so all of these angles have to be congruent or the same in order for you to figure out what each angle is. Go ahead and tape this in your notebook and move on to the next step. Okay, so now we're going to begin our lesson today on angles of polygons. So our essential question is, how can you find the sum of the interior angle measures of a polygon? We're actually going to skip this part about the exterior angle measures, and we'll cover that on a separate day. So some key vocabulary: convex polygon, concave polygon, and regular polygon. The biggest thing you need to know is polygon. And then regular polygon would mean that all sides and angles are equal. So go ahead and write that little note. So all the sides are the same length and all of the angles are the same measurement. Okay, so for our first example, example 1, it says find the sum of the interior angle measures of the school crossing sign. So we've got a polygon here. The first step is going to be to count the number of sides. So I have 1, 2, 3, 4, and 5 sides. Okay, now we're not going to keep splitting it into triangles. We're going to use the shorter way, which, remember, you take the number of sides subtract 2, multiply by 180 degrees. So you're going to want to follow along and work through the example as we do it together. So I know I have 5 sides, and I will subtract 2, and then multiply it by 180 degrees. 5 take away 2 is 3, and when I do 3 times 180, it equals 540 degrees. So that means within this pentagon here, this 5-sided shape, this angle plus this angle plus this angle plus this angle plus this angle would equal 540 degrees. 2 that you're going to try on your own. It says name each polygon and then find the sum of the interior angle measures. So naming it means use the reference chart based on the number of sides. What is the name of it? And then find the total degrees on the inside. So the first one, you're doing this green outline of the spider web here, not the square. And then number 2, you're doing the honeycomb. So go ahead, push pause, find the name and the degrees, and then push play when you're ready to check your answers. Okay, number 1, it is a 7-sided figure, so that is what we call septagon. And then when you do 7 minus 2, you get 5. Multiply 5 by 180, and that is a total of 900 degrees. Number 2 is a 6-sided figure, so a hexagon. So 6 minus 2 is 4 times 180 is 720 degrees. Okay, for example 2, it says find the value of x. So notice we have this missing angle that we want to find in this polygon. So step 1 is I need to know how many degrees are supposed to be in this polygon. The total, the sum, so what we've been doing with counting the sides. So first, count the sides. 1, 2, 3, 4, 5, 6, and 7. So I know there's 7 sides. So my shortcut to use my equation, 7 minus 2, multiply it by 180 degrees. 7 minus 2 is 5. And when I do 5 times 180, I get 900 degrees. So there should be 900 total degrees in this 7-sided figure here. Now what I'm going to do is just like I did when I had a missing angle of a triangle, I'm going to add up all of the degrees that are given combining these like terms. So when I take 140, 145 plus 115 plus 120 plus 130 plus 128, and I add those all together, I get 778. So I'm going to start an equation by saying, okay, I have 778 degrees plus this missing angle x, and that is equal to 900 total degrees that should be in this 7-sided figure. Now I'm going to solve my equation for x, so subtract 778 on both sides, and 778 is gone, it's 0. 900 take away 778 is 122. So this missing angle up here for x is actually 122 degrees. Okay, I'll work through a second example with you. So for the second example, we're going to start in the same way. Count the number of sides. So if I count 1, 2, 3, 4, 5, 6, 7. Well, that's easy because The one we did over here had 7 sides, so I know automatically it should have 900 degrees in it. That will be the sum. I don't need to rework all of this right here because it's the same exact thing. So I know there's 900 degrees in that polygon. Now, when I go combine my like terms of the degrees that they gave me, so I'm finding for the missing one, I add 112 plus 160 plus 121 plus 125 plus 128 plus 130, I get them all, equals 776. So I'm going to start my equation off by saying 776 plus x, this missing angle, should equal 900 degrees. Then when I go to solve for x, take away 776. 776 is 0, so 900 take away 776 is 124. So the missing angle x is 124. Now, I know a lot of you see that you don't really need to write this equation to solve the missing angle. You'll probably just say, oh, I know it's 900 take away 776, and that's the missing angle. That's fine for a problem like this, but know that we're going to get some expressions involved in our polygons, and it's probably going to be a little bit more difficult. Okay, on your own. I would like you to do number 3 and 4 on your own. Be careful, especially on number 4. You've got this angle right here that doesn't have a number on it. So make sure that when you add the degrees, you add that number there, or your missing angle will end up way too big. So go ahead, push pause, do number 3 and 4, and then when you're done, push play and you can check your answers. Okay, for number 3, you can see that there were 6 sides, and so if I take away 2, that's 4, and multiply by 180, that's 720 degrees. And then when I write my equation, when I combine all of these angles here and add them together like terms, 615. So if I write my equation, 615 plus x equals 720, and one second, go to solve, take away 615 on both sides, I end up with 105 for this missing angle. For number 4 then, I counted the sides. You can see there's 4 sides. Take away 2. Multiply by 180, that was 360. Most of you probably knew that off the top of your head. When I added up 80, 115, and don't forget the 90, you end up with 285. So 285 plus x equals 360. Take away 285 on both sides. You have x equals 75. Okay, for example 3 here, actually number 5. First we need to notice that we've got a polygon here. Look at what's different this time. Instead of just x, I have 2 angles that are not known, and they're not just x, they're 2x. So this is going to work a little bit differently, and this is why we're going to have an equation. But to start off, it's the same. So you're going to count the sides. I've got 1, 2, 3, 4, 5. Okay, 5 sides. Take away 2. Multiply by 185. Take away 2 is 3. And 3 times 180 is 540 degrees. Okay, now, when we go to write our equation, first we're going to look for the degrees without any variables. So if I add 145, 145, and 110, we add those. Oops. I get 400 degrees. So I'm going to start with 400, and then I have to pay attention to what I have for my variables. I have 2x plus 2x, so that's actually 4x. So I'm going to write plus 4x equals the 540 degrees that we know should be in this pentagon. So now when I go to solve, take away 400 on both sides. 400 is gone. 540, take away 400 is 140. Bring down 4x Careful, it's not just x this time, it's 4x. And undo that by dividing by 4. And so I get x equals 35. 140 divided by 4 is 35. Now be careful. This angle up here is not just x, it's 2x. So that means I actually would need to multiply by 2, x by 2. So 2 times 35 is 70. So both of those angles are 70 degrees. If I add 70 and 70 plus the ones that are given, it should, and it does equal 540 degrees. Okay, for example number 6 here, start with the same step. So count the sides. You can see we've got 6 sides. So 6 take away 2, multiply by 180 degrees. 6 take away 2 is 4, and 4 times 180 is 720 degrees. So that is what my equation is going to be set equal to. It's going to say equals 720. Okay, now I need to notice something about the angles on this polygon here. So first of all, I notice there's a right angle with no number. So I'm going to write a 90 there so that I don't lose track of that number. And then I also notice that this angle doesn't have anything. This angle doesn't have anything, but it has the same markings as the one labeled x. That means that these other two angles are also x. So I'm going to write in x so that I don't lose those. Okay, then what I'm going to do is I'm going to take the degrees that are given and add them up, 90, 150, and 10. If I add those together, 90 and 10 is 100, plus 150 is 250. And then I'm going to go look and collect all of the variables that I have. So I have an x, another one, and another one. So that is 4x. I'm going to write plus 4x, and then equals 720, because that's how many degrees are in this hexagon. Then when I solve, take away 250 on both sides. 720 take away 250 is 470 degrees. Bring down 4x. Divide by 4 on both sides. And x equals 117.5 degrees, which seems kind of wonky, but if you put in the 117.5 and add in the 10, the 150, and the 90, it does equal 720 degrees. Okay, and our last example for this lesson. It says this sign is in the shape of a regular hexagon. Find the measure of each interior angle. So when we look at it, each interior angle means we want to find how many degrees this angle is. Remember, if it's a regular hexagon, all of these angles are the same degrees. So once I found one of them, I found all of them. So first of all, I need to know how many degrees are in the hexagon. Count the sides. 1, 2, 3, 4, 5, and 6. So there's 6 sides. Take away 2. Multiply by 180. 6 take away 2 is 4. Times 180 is equal to 720 degrees. So there's a total of 720 degrees in a hexagon, but now all 6 of these have to add together to equal 720. So if I take the 720 and split it, divide it into 6 for those 6 angles, when I do 720 divided by 6, gives me 120 degrees. So each of these angles is 120 degrees. Okay, this concludes the portion of this screencast. You can go ahead and move on to the next step. Don't forget to use your resources from today, your notes, and both pages you put in your notebook.